Okay, so I wanted to go over the five basic parent functions that we looked at this week. And so linear functions we looked at, I just typed in the equation here, and this is f of x equals x. So it's the nice kind of identical or identity function where I'm just getting the exact same answer back. So if I plug in 5, I get the answer of 5. If I plug in even like 4.9, I get the same answer. So this is the identity function. It is a function, right? For every x, I'm only getting one answer back, but we wanted to look at like domain and range in particular. If I look at domain, I'm looking at this linear function, right? Anything that looks like this is a linear function. So this, I could say, -5, even though it's moved around a bit, it's still a linear function. Or maybe +7, again, it's still a line, it's still a linear function. So we're just looking at the parent function where we're not adding or subtracting, multiplying or dividing any number to it. We're just leaving it as x. And so when I look at the domain, I'm saying, how far wide does my graph go? So if I look at width, I want to say, does my graph kind of start and stop at a certain place on the left and the right? And I can see here 10 is definitely not it, right? -10 to 10, definitely not it, because my graph is extending even further than that. So if I extend it out to even 100, then I look and see, well, does my graph even pass that? Is maybe 100 the limit for my graph? Oops. And if I actually zoom out, we can see that 100 is not a good enough limit either, because my graph goes even further past that. Maybe I try 1,000. All right, so I'm still looking at my red graph and saying, is there a start and a stop, or does it just keep going on forever and ever to the left and the right? Right, so the more I kind of stretch out my domain, I'm still getting, if I zoom out a lot, I'm still getting places where my graph extends even 10,000. So when this happens, we know that infinity is our bound, right? -infinity to infinity. Oops. And so this calculator, I'll say, won't graph infinity. It's not a number, it's a concept. So we can't really graph a specific number for infinity. But we see that as we have numbers like 10, that's not good enough. My graph, oops. Let's try again. All right, it zoomed in a lot. So I zoomed out a lot. So if I see 10, 10's not wide enough. My graph's way past that. If I try 100, not good enough. I try 1,000, 10,000, 100,000. All these numbers are not wide enough for my graph, because at some point my graph even just gets further and further out from there. So that's why we write the domain as interval notation in parentheses, -infinity. Oops, try that again, to infinity. Right, because there's no bound. And the range is very similar, right? If I were to change this to looking at the y values, I would stretch again. I'm already at 100,000. That's not even wide enough. My graph goes out even further than that, right? Up and down now. We're just looking at the y values. Can I stretch my graph out and it go even further than, what number am I at? Maybe 1,000,000 now. I think I have 6 zeros there. I'm at 1,000,000, and that's still not big enough. So that means the domain and the range in this case are both -infinity to infinity. There's no bounds there. Same thing happens when we look at the quadratic. If I were to look at my domain first, right, I'm looking at the x's. How wide does my graph go? This looks like maybe -10 and 10 is good enough, right? But I'm just using that as a basis to show you that even -10 and 10, if I were to go up on my graph, or sorry, let me zoom in or zoom out. If I zoom out and look at my graph, there's actually a point, even though it takes a while, where even, -10 and 10 are still too small. So I can stretch it out to 100 and say, okay, that looks good. Maybe my graph starts at 100 and goes to, starts at -100, goes to +100. But if I zoom out a lot, my graph gets really, really skinny. Let's see if I can move it over. It gets really, really skinny, but we'll see that even that number is still not good enough. I'm going to try to zoom it out enough, and then, oops. There we go. And then get close in here. So if I look in here, my graph is a blue one. 100's not big enough, right? Even if I had to get really, really high up on the graph, because the graph just slowly widens up. So if I go really, really high up, it's wide enough where even 100, -100 to 100 is not good enough. I'm going to try 1,000, and then I'd go again. I just kind of zoom out and out and out until I see whether I have enough. And that's why this one, again, is infinity to -infinity, just like